So, hello guys. Last week I did a biweekly competition 33, and I finished all the problems under 15 minutes. But it could have been faster, but there's nothing to complain about. Like 15 minutes is my second fastest finish on any competitions, including the virtual contest I did. Um, I could have done it faster because so for example, the last problem you only need to detect the cycle in a 2D grid, which is which can be solved really fast if you have learned graph theory as a course, if you have taken a course in college, because it's just a very basic, simple idea stuff. But yeah, it took me like 5-ish minutes to think about the solution. So yeah, I could definitely have done it faster if I have taken the class, but there's nothing to complain about. I did it pretty quickly. So so the first one basically wants you to separate the number, separate the large integer with the dot. So yeah, it's pretty straightforward. Like if you're writing a big number, you usually separate it with a comma, right? But in this case, you're just separating it with a dot. With like every three digits, you separate it with a dot, starting from the right. So if you have 1, 2, 3, 4, you put a dot here, right? Starting from the last one, you have 3 numbers, then put a dot, then 1 number. And if it's large, you put it like this. And if you only have 3 digits, don't put a dot in front. And that's it. That's the case. So basically, I initialized because we have a string return. So I initialize the temp as string, and index is 0. So index is like the how many numbers I have traversed from the n. Because like every time I'm dividing the n by 10, so and I'm getting the digit by using like n% 10. So n% 10 is like 9. So that's the first digit I get. And this, the second, this is the third, vice, like etc. So yeah, you basically do a while loop while n is larger than 0. If so if in %3 is 0, it means that we need to put a dot. So basically means like if you're on the third number, yeah. So actually in IND starts at 0, so 0, 1, 2, and if I'm here, I need to put a dot in front of the string already established by 789, and then I put the number 6, right? So every time like in %3 equals to 0, I put a dot. And also if in is not 0, because when we initialize in, it is 0, right? So we don't want to put a dot right at the end of the number. So that's like the if statement. So we add a dot, and we add 1 to n, and then so n%10 is basically like the number, the last digit. So I append the last digit to the string in the front as I go, because like the first one I get is 9, second one I get is 8, for example. So I need to, when I concatenate the 8, I need to put it in front of the 9. So that's why I do this. And then n divided by 10, because like every time we need to get the next digit. And eventually, like, because if we have 0, it will already fail. Like n is already 0, will not execute, so the temp will be empty. But if we have 0, we want to return 0, right? So that's why if the temp is still empty, it means we don't have any digits. So we want to return the 0 string, or else we just return temp as we established, constructed. Yeah. Yeah, I don't worry too much about the time here. It's fine, 37.45. I don't worry too much about it. Because it's an easy problem, and you can always brute force through the easy problem. Okay, this one is really disgusting. Like it took me how long? It took me 10 minutes to come up with it with a bug. So that's 5 minutes extra. This is really disgusting, okay? And like I learned something on on Friday prior to this competition, and that was detrimental. Oh my God, like So I learned something called union Findset. Uh, it's a rarely used algorithm, but it's really useful when you want to union stuff. So when you want to group things together and see how many groups there are, like what group each element belongs to. It's a union Findset is a really helpful data structure. It basically does everything in an average of order of one, so constant time. But but strangely, this problem is not related to union Findset, and so I did that in the beginning. It cost me a lot of time, and so it's basically asking like you have a directed acyclic graph, so 3 has to go to 4, 4 cannot go to 3 with this edge, and it's acyclic, so there's no cycles. Um, basically, like if you start from 3, you can go to 4, 2, 5. If you start from 0, you can go to 0. You can go to 1, 2. You want you to find the smallest set of vertices from which all nodes in the graph are reachable. So, for example, in example 1, it should be 0 and 3, right? If you have two people starting at this and this node, they can basically reach all the nodes in the graph. So 0 and 3 is the smallest set of nodes required to reach all the nodes in the graph. So if you only have 3, you cannot reach 0 and 1. If you only have 0, you cannot reach 3 and 4. So you have to have both 0 and 3. And in this case, like you have to have 0, 3, and 2. Like it's the same reason as above. So like at first glance, it seems really scary, right? Like how do you do that? Like do you do a graph traversal or like even top sort kind of stuff? I didn't know. So it's actually deceptively easy. You only need to include the nodes that have no edges towards them. So they have to be a starting node with no edges coming into them. And it's really weird to think about. Just think about this. So for any nodes that does have an edge coming into them, for example, 4, it does have an edge coming into them. It is like a previous node can reach 4, right? 3 can reach 4. So you keep going back, and those nodes are all reachable. So for example, if you start on 5, right? If you have 5, 5 has an edge coming into 5, which is 2, which starts from 2. So you go to 2, and then like you you have 0 and 4 going to 2. So let's say 4. And if 2, like we can see, like if we want to reach 2, we only have to reach 4, right? As long as we reach 4, we can reach 2 and 5. So 2 and 5 are not necessary in the set. We only need to have 4 to make 4 to 5 all included in the traversal. So we only need to start at 4 to travel through 4, 2, and 5. And 4 does have an edge coming into it. So the thing is basically like we only need 3 to be able to traverse all those 4 nodes. So you see, like if a node has an edge coming into it, it means we can, like the previous node is better than choosing this node as a starting point. Because with this previous node, it can reach both itself and also the nodes we're currently at. See? So say like we want to choose 4, but 3 is a better option because 3 can reach both 3 and 4 and all the followings. So you always choose the ones coming, like if we have a node, if we're on a node and the node has an edge coming into it, we always want to choose the node before because the option before is better. And we eventually, if we trace back, keep tracing back, we eventually arrive at a node with no edge coming into it. So we cannot have a better option. So this is the best option for us to traverse through the graph. So that's why we only have to include all the nodes that have no edge coming into them. Yeah, so then it's like, it's a really weird problem, but the thinking and the coding is really easy. So basically, you just use a set, and so because the edges are like an adjacency list, and so it's represented as this. So if, for example, if 0 has an edge to 1, written as 0, 1. So basically, we want to include we want to add all the destinations like 0, like the 1, which is the destination of this edge, 2, and 5, 4, 2 into the hash set. So, and if a number did not appear in the hash set, which means it's not the destination of any edges, which means there's no edge coming from them. And then you just like find them and add them to a list and return. Easy as that. Okay. It's very weird problem. It's the hardest like one on the set. Cost me so much time. It's even harder than this one. So not like harder, but like just very disgusting. Okay, the third problem, it's when I did it, I thought it was pretty easy, I guess. So let's read the problem. So minimum number of function calls to make target array. Your task is to form an integer array nums from an initial array of zeros. So initially you have an array of all zeros. And you want to form an integer array nums from the original array. And return the minimum number of function calls to make nums from R, ARR. So let's read the function. So function modify. So if OP is 0, ARR index equals to ARR index plus 1. So basically, if OP is 0, you add 1 to the array element on index. And if OP is 1, then basically you multiply all the array elements by 2. So basically in this function, you can either add one single element by 1 or multiply every single element by 2. Okay, so let's read some examples. So for example, this. So in order to make this, the procedure is you first add 1 to the value at index 1, then multiply by 2, multiply by 2, and then add 1 to the first, like to the 0 index, and then add 1 to the second index, and you get 1 and 5. Yeah, so if you have 2, 2, you first add 1 to each index, which are 2 operations, because each operation you can only add 1 to one index. So there are 2 operations, and then you multiply them both by 2. So that's another operation. So it's the minimum to make it here is like 3 operations. So a good way in programming is you can think about solving the problem in reverse order. So instead of thinking how I can reach this value starting from 0 and starting from a 0 array, you think about how this array can be reverted back to the 0 array. Because like you basically, if you, and the operations you can make is like subtract 1 from an element and divide all the element by 2. Because like you're reversing the process. And it can actually be simpler if you think of it that way. Because like if you take the minimum number of steps to make the 0 array into this, if you reverse back the steps, they're going to be the same step because you're doing the same changes to the array, just reversely. So let's think about how we can like reverse it back to 0, 0. So we can we can subtract by 1, and we can divide by 2. So think about this: if we have at least 1 odd numbers in the array right now, so 1, 5, we have 2 odd numbers. If we have at least 1 odd number, we cannot divide them by 2, right? Because like, think about it. If we divide, for example, if we divide 5 by 2, it's going to be 2. But 2 multiplied by 2 is not 5. So that's an invalid step. So we can divide 2 for all elements only when all the elements are even. None of them are odd. Because like, if we divide 5, the step is not reversible in 1 step. We have to take 2 steps to make 2 to 4, then add it by 1. So we cannot divide odd numbers, because that would like decrease the decrease the answer incorrectly. So basically, we just like each time we do it, like if we want to divide the array by 2, we have to make all the elements even, right? And we have to subtract 1 from them, from the elements 1 at a time. So we need to make 1 0 and make 5 4. So basically, in our first iteration, we need to count how many odd numbers are in the array. And each time we have an odd number, we add 1 to the resulting step, right? Because we can only change one odd number to an even number per step. So that's what we do. We see like after 2 steps, it becomes 0 and 4, and then we can divide by 2. And then after we have 0 and 2, we then check, can we do another step? And because all the numbers are even, we can. So it's reverted back to 0 and 1. So 0 and 1, then we have an odd number. So we need to do another operation to reduce the 1 and make it 0. And that's like the idea behind the problem. So yeah, we need to do it in linear time. Should be pretty fine. So basically, we do an alternating step. We first make all the elements in the array even. So making this, divide by 2. Make the array even to be divisible again, then divide by 2. Make all the elements even, and then eventually reach 0, 0, 0. So let's see. Okay, so this is a main function, the main operations. So length, nums length. So basically started a new array because I don't want to erase the data in the nums. Yeah, I just copied it here. So while OK basically checks whether OK basically checks whether all the elements in the array are 0. So OK means there are still elements left to be divided or subtracted. So it will break when all the elements are 0. So if there are still elements left to be divided or subtracted, I clean the ARR. So clean basically like make all the odd elements even. And then if it's 0, just return. If the array is filled with 0, then return the result. If it's not, it means we can divide the even numbers in the array. So div ARR, so divide all the even numbers, then add 1 to result. Because like division only adds 1. It's only one operation, dividing the whole array, right? So it's basically just simple check function. OK just checks. So if any elements in the array is larger than 0, return true, means we still have elements left. But if it's not, just return false. And clean is basically like, so res is a global variable because it's easier to put them in those functions. Clean is basically like, it goes through the array. And if an element is even, if an element is odd, just subtract it and then add 1 operation because we have to subtract numbers 1 at a time. Then div is just like dividing all the elements by 2, and it should work. The time complexity should be n log n because we're dividing the elements by 2. So as large as it can get, it will only like take 60, at most like 2 times the power of 2 resulting from this. So like at most 60 operations to like clean the whole array. And each time we loop through the whole array. So each of the operation we do the complexity is order of n. So the total complexity is O n log n. Yeah, should be n log n because everyone's doing it that way. Okay, the last problem, just like simply detecting a cycle in 2D grid. So cycle is like, see, this is a cycle. Like elements can be cycled around like this. So if you just think about it closely, so say if you start on this index, you can do a breadth first search. So the first step, you have those 2 elements. Breadth first search strictly on the on the letters themselves, because we only a cycle only counts as a cycle if it's with the same letter. So B, this is B cycle, this is an A cycle, and this is a C cycle. So think about it. If we do a BFS, come here. This first step we reach this, second step we reach these two, third step we do this, fourth step we have those two, fifth step, and sixth step. See, sixth step from two different directions. From here we reach this A. From here we also reach this A. So that's like the way you identify a cycle. It's basically because you can your BFS, because BFS what comes with the BFS is a visited list. So you don't go back to the elements or you already visited. So you like before reaching this step, you know that these two elements are met by the BFS for the first time, because BFS doesn't go back. Those are the two new elements. So what you see is basically like if you have two different threads coming from different places, reaching the same element, it means that you can either go through this route and reach this, go through this route and reach this. So it's like a closed cycle. Because a more intuitive way to think about it is like if imagine this as a rope, okay? Imagine this cycle as a rope. You cut it from here. If you think about it, you cut it from here, you can see that you can reach this. You can reach this part from this side. You can also reach it from there, right? So if you paint this, imagine this as a rope. If you paint this block green and you cut it like this diagonally, you can see that there's green on this end of the rope and there's green on this end of the rope. So basically, if you have a cycle, it has to be reaching the same element from two different places, right? And so, for example, if you are here, do a BFS, second time, third time, fourth time, fifth time, you can see they reach a same destination. So basically, like if you think about the rope again, if you have this painted green, you have green here on the left, for example, the left end of the rope, and you have green here on the right end of the rope. Think about it. If you like straighten the rope. So basically, like if you have green on two ends of the rope, you can put them together, form a cell full of like fully painted green, and it becomes a cycle. It becomes like a circular rope. So that's the basic idea behind the BFS. So basically, you need to find like, so when you reach, so if you're on a certain step in the, on a certain like loop step in the BFS, if like two nodes, like two elements in the BFS reach the same node, reach the same position, then you know like there's a cycle. So basically it's a standard DFS. So DIR, again, used for like going left, right, top, bottom, and visited. And so basically like you just do a BFS on all the elements in the array, in the grid. Because basically like you can have a cycle starting from here, or you can have a cycle starting from here. So basically you need to make the starting, like you need to make each element in the array as a starting point, because there's a possibility that the cycle can start from any element in the array. You can start from here, you can also start from here. So that's why you do like BFS on all of them. But if you already done the BFS on a whole cycle, those places are marked as visited, so you don't have to, when you arrive at a second node or like the third position, you don't have to do the BFS thing again because it's already identified as a cycle. So yeah, so if it's not visited, then we do a BFS. And if BFS returns true, which means it's a cycle, then we just return true. Else, if there's no cycle, we return false. So let's look at the BFS function. So yeah, if it's visited, then just don't do anything. Just return false. This is not a cycle. Q is like the Q for BFS. So we first add the IJ pair, which is like the element, the location of the element, row and column of the element that we are on right now. And char C means the current character of this location. So if the location is 0, 0, char C is C. There's a letter here, C. So yeah, basically IJ is 1. Okay, so while Q is now empty, we basically get the size of the Q and just like remove all the elements according to that size, because we have a potential of adding new elements into the queue. So we don't want to make the size dynamic. And so for each of the P's a pair only has like A and B. A represents a row, B represents a column. So pair is like it represents the location of a certain element in the array. So we first add this pair, new pair IJ, means we start from here. It's like a valid location. So then we basically like traverse through the dir 4 times. Basically each time it gets us either the left, right, or top, bottom block according to the IJ or according to the pair position. So basically that's how we do a BFS on 4 directions. So if the new generated location is out of bound, or it doesn't equal to the character input, because we only want a loop that has the same character. If it doesn't have the same character, then don't do anything to that cell, just pass it. And if it's not visited, if it's visited, and if it's, so basically each time, so if the node first, let's see if the node is not visited, we put so if we are here, we basically do a BFS on those two, right? And as soon as we find like those two are valid positions to go to, we mark them as visited with the lens, like with the step we're at in the BFS. So this will be marked 1. And on the second step, this block on the visited list will be marked as 2. So indicating how many steps we have taken. So then we'll add the pair because they are not traversed yet. And so let's think about this. When we, for example, when we reach the end of, when we are here, we have those 2 blocks of 5. And first we remove this element. For example, we remove this. And we see, okay, so we see like this element is valid, right? It has not been traveled at step 5, has not been yet traveled. So we put this visited as 6. So the visited array has at this location is marked as 6. Then we have this. Then after we do the BFS on this node, we do the BFS on this node, and we see you can reach that position too, right? And then we check the number on the visited, because it's already marked as visited. We check the number here. So for example, if this number is 4, I know that like if I'm 5 here, it's 4 here. So I mean, it means like there's not a cycle. I just like reached the backward node, the node that has been traversed before. But if it's a 6 here, it means an element with step 5 has already identified this element as the next step, right? Which is this. I identified this as the next step of this, which means we have 2 different threads, 2 different like paths coming to the same node. It only works when this is 5 and this is 1 plus 5, which is 6. because it means that the previous 5 identified this 6. And now I'm on 5. I also need to identify this as 6. Like I also see this as 6. So it means like I have 2 different paths at 5 reaching through the 6th node. So that's what I determine here. So if the visited has an LEN plus 1, then I return true. If it's like a 4 here, it means it's just a previously traveled node. It's not the next step. So I just don't do anything. So that's the basic idea. It's a twist to the BFS, which is pretty interesting if you think about it. You can use a Boolean. Visited lists are always Boolean, but if you use int double arrays, you can actually put more information in the visited list. And in this case, it can be really helpful. And great. So let's see how it does. Oh, it's pretty fast. Okay. So not too much to complain about this competition. I think I did pretty well, considering I haven't learned those problems before. So yeah, thank you guys for watching, and see you next week.